Today we're going to evaluate the indefinite integral of tangent raised to the power 5x dx. To evaluate this indefinite integral, first we're going to expand this expression into tangent cube x into tangent square x dx. Now why did we do it? Because we're going to use a trigonometric identity which states that 1 plus tangent square x equals to secant square x, or we can write that tangent square x is going to be equals to secant square x minus 1. Now we're going to replace this value in here, so we would have this as tangent cube x into secant square x minus 1 dx. Now we're going to multiply this in here, so we would have this as integral of tangent cube x into secant square x dx minus integral of tangent cube x dx. Now we can again expand this tangent cube x, so we're gonna have tangent cube x into secant square x dx minus integral of tangent x into tangent square x dx. Now we're gonna again replace the value of tangent square x from secant square x minus 1, so we would have integral of tangent cube x into secant square x dx minus integral of secant square x minus 1 into tangent x dx. Now again multiplying it inside, we would have integral of tangent cube x into secant square x dx minus integral of tangent x into secant square x dx plus integral of tangent x dx, because negative and the negative is going to be positive. So now we have three different indefinite integrals. So first two are going to be used by a similar method, whereas the third one is going to take a different method or different approach to solve this. So first we're going to solve the third one. So the integral of tangent x dx. First we're going to simplify it into sin x divided by cos x dx, and we will assume that value of u equals to cosine x. So derivative of u is going to be sin x minus sin x into dx, or minus du equals to sin x into dx. So now we can see that sin x dx is going to be replaced by derivative of u, negative derivative of u, and cos x is going to be replaced by u. So we would have integral of minus derivative of u divided by u, and the antiderivative of u is going to be minus ln mod u plus c. C, where c is a constant of integration. Now we're going to place the value of u, so we would have minus ln modulus of cosine x plus c. Now we can also write this as ln cosine x minus 1 raised to the power minus 1 plus c, because ln a raised to the power b equals to b times of ln a. So we're going to use this identity, and so we can write this as modulus of secant x plus c. So we have the answer for the third one, which is ln secant of x. Now we're going to place this value in here, so we would have ln modulus of secant of x. Now for the first two, we're going to assume the value of u to be equals to tangent of x So derivative of u is going to be secant square x dx. Now we can see that here the secant square x dx is going to be replaced by du, and tangent of x is going to be replaced by u. So we would have expression as integral of u cube into derivative of u minus integral of u into derivative of u plus ln mod of secant of x. Now if you were to take the entire derivative of u raised to power 3, that's going to be u raised to power 3 plus 1, which is 4 divided by 4, minus u raised to power 1 plus 1, that's going to be 2 divided by 2, plus ln modulus of secant of x plus c. Now we're going to replace the value of u, so we would have tangent raised to power 4x divided by 4 plus, sorry, that's going to be a minus tangent square x divided by 2 plus ln mod of secant of x plus c. So that's going to be our final answer.